Okay, here's the practice test that we did in class. I'm just going to go over the answers. I want you to remember when you're looking at these things to read everything. Before you do any interpretation of data, make sure you understand what the columns of the chart are, and when you're reading the questions, read the questions carefully. A clam farmer has been keeping records concerning the water temperature and the number of clams developing from fertilized eggs. His data is shown. Okay, so he's showing that the water temperature, and if you look as it increases, it seems to increase the number of clams until about 35, and then the number of clams developing starts to decrease. So from this you can see that, you know, the optimum temperature for clam development is about 30 degrees Celsius, and you know, once you get past 50 degrees, the clams aren't developing. And that sort of makes sense because 50 degrees Celsius is quite hot, and so the sperm and the eggs would not be viable in the water. Okay, it says if a clam farmer wants to increase his yield of clams, that's how many clams are produced. That's what yield means. It also means slow down for those of you who are just getting your driver's license. But when we're talking the amount of things, we can also use the term yield. If he wants to increase his yield of clams, what water temperature should he maintain and why? Well, the biggest yield would be here at 140, okay? So that's 30 degrees Celsius. And the reason that he should maintain that temperature is because at 30 degrees he gets the optimum or highest number of clams produced. Okay, what is the minimum temperature necessary for a clam to develop? And explain. Well, let's take a look. The only temperatures we're given here is here. The minimum temperature is the lowest temperature at which the clams will develop. And our very first temperature 15 is the lowest temperature at which you will see clams develop. Okay? And so if you look at the chart, 15 degrees has 75 clams. There's no temperature below that, so that's the minimum temperature. Okay. 30 degrees Celsius is approximately 86 degrees Fahrenheit, and you guys should be able to understand this. We'll talk a little bit more about the metric scale, but that's what scientists use, so you have to be familiar with it. What time of year do you think spawning typically occurs? Now, don't forget, spawning is where the female organism lays her eggs in the water, and the male ejects his sperm in the water, and the sperm and the egg meet, and the egg becomes fertilized, okay? So that's what spawning is. So what time of year do you think spawning typically occurs? Well, let's take a look. If we look at the water temperature, around 25 or 30 is about when you get the highest number of clams developing, okay? And 30 degrees is the optimum, and 30 degrees is about 86 degrees Fahrenheit. Now, any of you guys who swim, we know in the Gulf of Mexico, the Gulf is quite warm in the summertime, so you can interpret this data to say that 86 degrees Fahrenheit would occur in the summertime, and so we can say during the summer, okay? Make a prediction about the likelihood of finding clams on the shores of Washington versus the shores of Florida. And here they want you to understand where Washington is, and as a 10th grader, you should know that Washington, the state of Washington, is in the Pacific Northwest, so the northwest coast of the United States on the Pacific Ocean. And the Pacific Ocean is quite chilly all year round compared to what we're used to in the Gulf of Mexico. So the likelihood of finding clams on the shores of Washington, well, you might find clams, maybe not these clams, clams that are more well adjusted to colder temperatures you may find there. I know in the Northeast, which is where I have experience, there are lots of clams there. But we have to remember that as compared to Florida, they're less likely to be found on the shores of Washington. Identify the independent and dependent variables. So the independent variable is the one thing that they changed If you guys remember my I and the one thing that they change, well, what did he change? The water temperature. And the dependent variable is the thing that you collect the data on. The dependent variable is the data. And what did we measure? We measured the number of clams. So that's the dependent variable. This is the independent
Any
variable.
freshman who is interested, you are invited to attend the freshman class board meeting at this.
Okay, sorry about that interruption. Okay, the next one is the thickness of the annual rings in trees. We talked about this in class about trees. When you take a cross-section of the tree, the rings indicate a year's growth, and thick rings will indicate good growth, and thin rings will indicate poor growth. And it says the thickness of annual rings in trees indicate what type of environmental situation occurred during the tree's growth. Ooh, there should not be an apostrophe in there, and I apologize. Thin rings usually indicate poor environmental conditions, such as drought, forest fires, or insect infestation. A thick ring, however, indicates favorable conditions. That means good. Favorable means good. Samples of recently felled trees, and don't forget, felled means taken down or chopped down, or typically scientists won't chop down trees. They don't want to kill them, but trees fall in the forest. So recently fallen or felled is another acceptable term. So samples of recently felled trees were taken and the following data was collected. Okay, so let's take a look. We're talking about the different years, age, the thickness of the rings in forest A and thickness of the rings in forest B. Okay. And during which 10-year period was forest B experiencing the most favorable weather conditions? Okay, so if we look here and we see the one where we see the most growth, so there's 0.3 growth there, there's 1.1 there, this one's 1.2, that one's 0.2, and that one's 0.5. So between year 30 and 35 in forest B had the most growth. And that's because the difference between the ring thickness of this and the ring thickness of this is the greatest. And what was the average thickness of the annual rings of 40-year-old trees in forest A? Well, we didn't give you 40, okay? But 40 is halfway between 30 and 50, okay? So you take 30, which is 3.5, 50, 4.5, add them up and divide by 2 and you'll get the 40, okay? What might have occurred between year 20 and year 30 in forest B? Well, let's take a look. It went from 2.5 to 3.6. So I would say 2.5, they might have had a drought during that year, and year 30, they probably had a pretty decent weather conditions, okay? And what might have occurred between year 30 and year 35 in forest A? Well, let's take a look. Year 30 is 3.5 and year 35 is 3. So the growth ring was smaller in year 35. And what we have to understand about the growth ring being smaller is that there was probably some kind of condition that prevented the tree from growing as big as it had in the previous year. And the condition could have been drought, forest fire, or insect infestation.